Good day, class. Today we will discuss a new lesson, which is sigma notation or summation notation. When we say sigma notation or summation notation, it is used in simply writing equations in a shorter way. And this is the most commonly used notation in statistics, which is represented by this Greek symbol, sigma. Now let us study the parts of a summation notation. The x sub I here is what we call element. And in an element, we can use any variable to represent an element. I here stands for the index. 1 means that is your lower limit or your starting point. The n here is your upper limit or your stopping point. And this sigma or this symbol is known as summation symbol. And it is read as the summation of x sub I from I equals 1 to n. I repeat, when we read this one, it will be the summation of x sub I from I equals 1 to n. I hope you understood. Okay, let us proceed with our first example. Let us try to read first before we expand the summation. So number 1 is read as, very good, the summation of 3k from k, which is 1, to 5. I repeat, the summation of 3k from k equals 1 to 5. Very good. Now let us expand the summation. From the term itself, summation, we will add the following. We will just substitute the value of k starting from our lower limit, which is 1, and we will stop at 5, which is our stopping point. So this becomes 3 times 3k, k will now become 1. So 3 times 1 plus, because summation we will add 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. We will now stop at 5. Why? Because that is our stopping point or our upper limit. Now let us expand the summation. Let us simplify the following. 3 times 1 is 3 plus 3 times 2 is 6 plus 3 times 3 is 9 plus 3 times 4 is 12 plus 3 times 5 is 15. Now class, this is the expanded form of the given notation. But if we were asked to get the sum, then we will just add the following. So we have 3 plus 6 plus 9 plus 12 plus 15, that is 45. So if we will read again the given, the summation of 3k from k equals 1 to 5 is 45. Very good. Next, number 2. Number 2 example is read as, very good, the summation of 2j plus 1 from j equals 0 to 5. Meaning to say, we will substitute the j value here from 0 and we will stop at 5. So let us write 2 times our lower limit or our starting point is 0. So j now will become 0 plus 1 plus 2 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1 plus 2 times 5 plus 1. We will now stop at 5 since this is our stopping point or the upper limit. Now let us simplify. 2 times 0 is 0 plus 1. So let us write it step by step. 2 times 0 is 0 plus 1 plus 2 times 1 is 2 plus 1 plus 2 times 2 is 4 plus 1 plus 2 times 3 is 6 plus 1 plus 2 times 4 is 8 plus 1 and 2 times 5 is 10 plus 1. Simplify. 0 plus 1 is 0 plus 2 plus 1 is 3 plus 4 plus 1 is 5 plus 6 plus 1 is 7 plus 8 plus 1 is 9 and plus 10 plus 1 is 11. This is the expanded form of the given notation. Again, if you were asked to get the sum, we will just add the following. And it will give us 0 plus 3 plus 5 plus 7 plus 9 plus 11 is 36. So the summation of 2j plus 1 from j equals 0 to 5 is equal to 36. That is for number 2. Next example, number 3. Let us read first the given notation. It is read as, very good. The summation of negative 1 raised to m minus 1 over m from m equals 1 to 5. So all the m variables here will be changed starting from 1 up to 5. Let us now write our solution. Negative 1 raised to, start at 1 minus 1 over 1 plus negative 1 raised to 2 minus 1 over 2 plus negative 1 raised to 3 minus 1 over 3 plus negative 1 raised to 4 minus 1 over 4 plus negative 1 raised to 5 minus 1 over 5. Okay, next, let us simplify. So negative 1, 1 minus 1, that is 0, over 1, plus, copy negative 1, and then 2 minus 1, that is 1, over 2, plus, negative 1, 3 minus 1, that is 2, and then, negative 1, 4 minus 1 is 3. Copy the denominator 4 and then negative 1, 5 minus 1 is 4. So raised to 4 over 5. Simplify. Negative 1 raised to 0, that is 1. And then divided by 1 is 1. Plus. Okay, let us analyze first. Again, if your base is negative and the exponent is odd, meaning to say the sign will be negative. So we have here negative 1 over 2. Next, the exponent is even. So this will be positive, 1/3. Next, the exponent is odd. So the sign will be negative 1/4. And last, even exponent, so plus 1/5. This is the expanded form of the given notation. Okay? So if you were asked to add, then you need to add. And take note, class, that when you analyze the expanded form, the thing that you will notice is the signs. And you can say that the signs are alternating. We have positive, negative, positive, negative, positive. If this will be the case, your main clue here will be this one. You will use this formula, negative 1 raised to m minus 1, whenever you encounter alternating signs. Okay, later on, I will share you an example wherein we can apply this formula in using for the alternating signs of the terms. Okay. Now let's proceed with example number 4. Let us read first the given notation before we expand. Number 4 is read as, very good, the summation of 2 raised to I plus 1 from I equals 0 to 5. So the I variable here will be changed to 0 up to 5. So let me put my solution here. Let us substitute 2 raised to 0 plus 1 plus 2 raised to 1 plus 1 plus 2 raised to 2 plus 1 plus 2 raised to 3 plus 1 plus 2 raised to 4 plus 1 and then 2 raised to 5 plus 1. We stop at 5 because that is our stopping point. Now let us solve. 0 plus 1 is 1 plus 1 plus 1 is 2 plus 1 is 3 plus 1 is 4 plus 1 is 5 and 5 plus 1 is 6. Let us simplify. 2 raised to 1 is 2 plus 2 raised to 2 is 4 plus 2 cubed is equal to 8 plus 2 raised to 4, that is 16, plus 2 raised to 5 is 32, and then 2 raised to 6, that is 64. This is the expanded form of the given notation. And if we are asked to get the sum, then just add 2, 4, 8, 16, 32, and 64. Understood? Let us proceed with the following examples. Rewrite the following series in sigma notation. For number 1, remember, class, that you need to know if it takes the form of an arithmetic or geometric. Let's try. 2, 4, 6, 8, 10, and 12. Is it arithmetic or geometric? Very good. It is arithmetic. Now, let us get the common difference. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. 10 minus 8 is 2. 12 minus 10 is 2. Again, first thing that you need to do in rewriting the series into sigma notation is to identify whether it is an arithmetic or geometric. The next step that you need to do is to get the common difference or common ratio. Since 2 is our common difference, we will write the first thing. So we need to write our sigma symbol or our summation symbol. Then write the common difference with 2 here in our element. Then choose a letter or variable that you want to use. Example, I want to use letter K. So So let me use that variable here. I will put k. Then check if it fits. 2 times, if our starting point will be 1, let's say k is equal to 1, let's check. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6, and so on. Based from the series, if 1 is our starting point, what will be our stopping point? We have 1, 2, 3, 4, 5, and 6. This is now our answer. The summation of 2k from k equals 1 to 6. So if we will substitute the values of k and we will stop at 6, we will have 2, 4, 6, 8, 10, and 12 series. Alright, let's proceed with number 2. Since all the numerators are 1, let us only focus on the denominator. 1/4 plus 1/8 plus 1 over 16 plus 1 over 32 plus 1 over 64. Same numerator, let us focus on the denominator. First, let us check whether it is a geometric or an arithmetic. Very good. There is a common ratio. Therefore, this is an example of geometric series. And let us compute for the common ratio. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. 64 divided by 32 is 2. The summation now will be like this. So focus on the denominator 2. That is our common ratio. Now class, what do we multiply with 2? Since the common ratio is 2, we can say that there are exponentially increasing. They are exponentially increasing. Therefore, there should be an exponent here, because they are increasing. Since this is 2, let us raise it to n. They are all multiplied by 2. Therefore, our base is 2. Let us say our n is equal to 1. If n is equal to 1, 2 raised to 1 is 2. But not 4. Meaning to say, we should not start with 1. So, where do we start? Very good. We should start at 2. If our starting point is 2, let's check. 2 raised to 2 is 4. 2 raised to 3 is 8. 2 raised to 4 is 16, and so on. Now, what will be our upper limit? We have 6. Very good. Our upper limit is 6. So let us check. 2 raised to 5, that is 32. And then 2 raised to 6, 64. The numerator will stay at 1. This is now our answer. Now let's proceed with our third example. The first thing that you need to do is always analyze. And what can you see? Very good. It contains alternating signs. If you have alternating sign, you will use the formula that I presented a while back, which is this one. -1 raised to m minus 1. We will use this formula for alternating signs. So let's write our sigma here. For our numerator, we have negative 1 raised to m minus 1. And for the denominator, identify first if it is arithmetic or geometric. What is the answer? Very good. It is arithmetic. Meaning to say, we need to get the common difference. So 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. And then 16 minus 13 is 3. Now, that is our common factor. We will put 3 on our denominator here. And if this will be 3m, and we will start with 1, let's say m is equal to 1, let us try to substitute. Let us focus on the denominator. 3 times 1 is 3, but not 4. So what do we add with 3 to become 4? Very good. We need to add 1. Let's check. 3 times 1 is 3 plus 1 is 4. 3 times 2 is 6 plus 1 is 7. 3 times 3 is 9 plus 1, 10. 3 times 4 is 12 plus 1, 13. And then, and so on. Next, what will be our stopping point? If we start at 1, where do we stop? We have 1, 2, 3, 4, and 5. Meaning to say, if m is 5, 3 times 5 is 15 plus 1 is 16. So let us check first the numerator if it really fits. So negative 1 raised to 1 minus 1 is 0, that is positive 1. The negative 1 raised to 2 minus 1, which is 1, that is a negative 1. So this is correct. This is now the answer for number 3. That's it for today. I hope you learned something. Thank you and goodbye.